To see the application of the previous theorem, that is Lemmy-Sheffield's theorem, we take an example. That is, let x1, x2 up to xn be the random sample from the uniform distribution with the probability density function that is 1 over theta, and it ranges from 0 to theta, and theta is greater than 0. It is already shown that in the previous module that the distribution of the maximum, that is yn, that is maximum of x1 up to xn, is sufficient statistic for theta. ये हम sufficient statistic already uniform distribution के लिए sufficiency के module में proof कर चुके हैं. Now here we show that it is a complete and find the minimum variance unbiased estimator of theta. तो sufficiency हम already proof कर चुके हैं. हम further आगे हम इसकी completeness को proof करेंगे और इसके लिए minimum variance unbiased estimator of theta find out करेंगे. So let's see how we proceed. We know that yn, we know that the distribution yn, which represent the maximum of x, is, that is g of yn theta, and that is equal to n yn raised to power n minus 1 over theta raised to power n, 0 less than yn less than theta. To show it is complete, suppose that to show it is complete, suppose for any function that is u of, let's say, yn, and for any theta greater than 0, the expected value of u of yn, that is equal to 0, and that is integral 0 to theta u of yn into the PDF of the maximum, that is n yn raised to power n minus 1 over theta raised to power n dyn, that is equal to 0. Since it is given that theta is greater than 0, so we have integral 0 to theta u of yn, that is yn raised to power n minus 1 dyn, that is equal to 0. Now differentiating both sides with respect to theta, we get u of theta into theta raised to power n minus 1, that is equal to 0. So we have already know that as theta is greater than 0, so which means that theta raised to power n minus 1 is also greater than 0, and this implies that u of theta is equal to 0 for all theta. Thus yn is complete. To find the minimum variance unbiased estimator of theta, we proceed as by taking the expected value of yn, that is expected value of yn, that is equal to integral 0 to theta yn into yn raised to power n minus 1 over theta raised to power n dyn, and this is equal to further when we are going to simplify, that is 0 to theta n yn raised to power n and theta raised to power n is a constant. इसको भी बाहर निकाल दें. So that is actually simple dy over n. So when we take the integration of this and putting the limits, we get that is n over n plus 1 into theta. So hence the minimum variance unbiased estimator of theta is, this is going to the other side, that is n plus 1 over n into yn. So the minimum variance unbiased estimator of theta is this one.